Have you ever wondered what it takes to make a buffing pad? Well, today we're going to learn. Mike Phillips with AutoGeek.com, and we're on location in Oconomowoc, Wisconsin at the Lake Country Manufacturing Corporate Office and Training Center, and I'm here with the Technical Manager for New Product Development, David Patterson. David, how you doing?
I'm doing awesome. Thanks for coming.
You know, there's a lot of science that goes behind making a great buffing pad. Isn't that right, Dave?
Absolutely. There's a lot of variables and a lot of things that are additives that we can add to a foam to make it do what we want.
So, you know, a lot of people think foam is foam. For example, this is a camera case, and a lot of people have seen the camera case and it's got this kind of convoluted foam, and if you just cut that in a circle, could you just buff paint with something like that?
Well, not quite. We use technical foams or boutique foams that are specially made for polishing paint or polishing other materials, but they're engineered for usage on machines that are going to create a lot of heat or create a lot of friction. Yeah, different things that most foams don't experience. So with chemistry and with engineering, we can make foams do different things by fine-tuning them and creating what we need.
So there's a lot more to foams than just the foam that the average person sees.
Yeah.
Okay. And this is where you can go in and modify the foam formula to make it behave in a way that you want it to behave. And that could depend upon, for example, the type of tool you're going to use it on.
Absolutely.
We have rotary buffers, we've got long stroke orbital polishers, we got short stroke, large pads, small pads, compounding, polishing, even waxing. And then there's things like reticulated and non-reticulated. Yeah. So there's a real science to actually the foam. It's not just foam.
Yeah, it's much more than that, and once you kind of get a vision inside that, kind of changes the way you think about them too.
And then, because you're Lake Country, all your foam formulas, of course, are proprietary to you. So this is a real science that Lake Country owns.
Yeah, we spend a lot of time with foamers and chemists to create foam formulas that perform well for us, and we have a lot of proprietary and exclusive formulations to Lake Country.
Okay. Now, besides foam pads, there's also what I would just generically call fiber pads.
Yeah.
So you have like wool cutting pads, but you also have microfiber pads, which is in the context of the car detailing world, that would be a newer type of pad. Yeah. But let's talk a little bit about the fiber side of buffing pads. Well, for example, what do you got here?
So here's your traditional style wool pad. It's a tufted type of sewing where it has long twisted tufts of wool. And this is going to be your traditional rotary wool pad. I'm sure you used a lot of these. I used a lot of them. You know, it's still a top selling pad, and it creates a lot of cutting ability. And fibrous pads like wool or microfiber actually are abrasive. So mixed with your liquid abrasives, you can control the amount of cut or finish that you're getting.
Yeah, so if you want more cut, then you would use a fiber foam like this wool cutting pad with your compounder polish versus a foam pad, which would be, even though you have a foam cutting pad, it's a lot less aggressive than all these individual fibers that actually act as a form of abrasive.
Yeah, absolutely.
And so that's kind of one of the differences between foam and fibers. You get these different benefits, or in this case, a more aggressive cut by using a fiber pad.
Absolutely.
Now, this is a traditional wool pad for a rotary buffer. This wouldn't work on a DA, would it?
No, it wouldn't. It's too large of a pad. It's too heavy of a pad. And because of the style and the fibers used, it's not the ideal choice.
Yeah, I know that from practical experience, when I've tried to use something like this, and other guys have tried it, the fibers just tend to wiggle around.
Yeah.
So it's really something for a direct drive type tool.
Absolutely.
But over here, I see you've got a microfiber pad. So now, how is this different than a traditional wool pad where it will work with an orbital polisher?
Well, the way I like to kind of look at it is treating or looking at those strands like pieces of spaghetti. You know, let's just say they're hanging. So when you have a dual action tool, the shorter strand or the shorter of the pile height, the more effective that pad is going to be because it has less movement to kind of move around with that orbiting.
So it's able to transfer the energy from the tool to the surface of the paint, which is what most of us are trying to work on.
Yeah.
Or fiberglass or plastic or metal, other things that we tend to polish in the car detailing world.
Yeah, absolutely.
And as you can see real easily that the pile length, the pile height of this is much shorter than something like this. What is this, by the way? This is 1 inch?
That's
inch and a quarter?
an inch and a half.
Okay.
And it's a 100% twisted wool, so that's a heavy cutting pad.
And this would be considered nowadays a fairly long pile length wool pad.
Yeah, absolutely.
And then what's the pile length on this?
The pile length in this is about 8 to 10 millimeters, so it's very short, but it creates a very good cutting ability on any type of DA polisher, whether it has a a 6 or 8 millimeter throw like some of the smaller machines, or up to the 15 and 21 millimeter orbits.
Okay, so we got wool pads, microfiber pads, and here's kind of a strange looking one that maybe some people have never seen before. What type of fiber pad is this, and what kind of tools would you use this on?
So this is actually a knitted wool pad, but it also has foaming in it. We call it a hybrid foamed wool pad. It's similar to what you'd see in a purple foamed wool, but it actually has a higher foam content. So the pad tends to stick together a little bit better. It offers a little bit more cushioned feel. So because it's a knitted pad, this pad is sewn differently than a tufted pad, where the fibers from the sheep are shaved and then it's knitted into a material, then laminated together.
And what type of tool would you typically use this type of pad on?
So these are really nice for using on a rotary tool when maybe you don't want to use a twisted wool. It provides close to the same amount of cut, but just a little bit less. But it tends to shed a little bit less. So if you still need a wool pad and you're in a clean area, that's a great pad. But ideally, I really like these on a forced rotation machine like the Flex 3401.
Gotcha. And there's also some more forced rotation tools coming onto the market nowadays.
Absolutely.
So you're going to have a bigger market share for these types of pads.
Yeah.
And so what this does then is, with your different option for foam pads and then fiber pads, is it kind of gives you something for no matter whatever you're working on, you can adjust the level of cut you have to get to the goal, which in our case is usually something beautiful and shiny.
Yeah, perfect.
Now let's go back to foam pads, because out here on the table you've got a number of different types of foam pads. And I know from my experience as someone that teaches detailing classes, when people come to my classes, they ask me, Mike, how do I know which color of foam pad to use for what I'm trying to do? And that's where I get to share with them, well, the problem with this is there's no universal color code, which I'm sure you've had to experience before.
Yeah.
And that's where you just need to learn to work with the pad manufacturer and learn what their color code is for their different pads.
Yeah.
And I know that in your CCS and your flat pad line, like you have over here, orange would be cutting, but in your Hydrotech line, orange would be polishing.
Correct.
Yes, you see, it can confuse me. I'm sure it can confuse other people, but that's what things like this video are for, to help solve that confusion.
Yeah.
So let's just go ahead and take a look at these two pads you have down here. Why don't you explain the difference between the surface of these pads?
Yeah, so when we talk about our original foams, which our original foams are still one of our most popular pads. They've been around since the beginning, and even though we come out with new technology and advanced foams, advanced pads and techniques, there's still going to be the traditional user that wants to have the same pad that they've been using. If it works, don't.
So when you talk about a traditional foam pad, I'm guessing you mean this flat pad design. Real simple. This is what you call an open cell foam.
Yeah, absolutely.
And I can tell because I can actually, don't do this at home, because you don't know whose lips have been on a foam, but one way you can tell an open cell or non-reticulated foam is you can blow air through it easily.
Yeah, and actually when you blow it through, our open cell is a reticulated, whereas a closed cell is the non-reticulated. But yeah, that's the exact way that you'd want to test it for your own personal use.
So this is more of a real traditional foam pad. It's just flat. I see there's a bevel here. And this is actually made for a 5-inch backing plate for a lot of the popular orbital polishers on the market today.
Yeah.
Okay, now this one is very unique looking compared to that. Tell me about these little divots here. What are these for, and what is the benefit to this when a guy is buffing?
Yeah, so the CCS, our CCS pattern or design is a collapsed cell structure. It's using heat and pressure to partially collapse foam cells. So it doesn't melt them to make them hard, but it partially collapses them to prevent your polisher liquid from absorbing, but it also works as a way to break friction, reduce heat, and reduce pad hop or chatter if you're using it on a rotary buffer.
Gotcha. So just by changing the face of the pad, you can change the buffing characteristics of the pad.
Absolutely. You can change the buffing characteristics. You can change the way that it generates heat on the surface.
Product absorption?
Yeah, product absorption and the longevity of that product.
And also, don't the pockets act to kind of hold the product and then dispense them as you're buffing to give you a good buffing cycle?
Yeah, absolutely. So because of those pockets and because they don't absorb, it helps release that polish during your working cycle and increase that working cycle so that you have a longer area. Some of the water-based polishes tend to have a little bit of a shorter working area or shorter sized ideal working area, and that helps increase that a little bit.
And that's a real simple way to see how you can change one aspect of a pad and then change the buffing characteristics of it.
Yeah.
So this is the CCS, this is the traditional flat pad. What about these other pads? And I'm looking at this pad over here and I see that it's like multicolored. There's a different level of foam there. Let's talk about these.
Yeah, so these are actually what we call our HDO, or our heavy duty orbital buffing pads. These pads will work on any machine, but really what they're designed for is long throw orbital machines. Kind of like your Rupes or Griot's machine, or even the Flex 15 millimeter.
So the tools that have the longer orbit stroke length.
Yeah.
So a traditional orbital polisher, kind of the one that kind of kicked off the industry, would be the Porter Cable.
Yep.
And it had an 8 millimeter orbit stroke length. And what that means is as the pad is spinning in a circle, it makes a small circle inside that circle. That's the orbit stroke length. And nowadays we have a lot of these long stroke orbital polishers, and instead of 8 millimeter, they go all the way up to 12, 15, and 21. So they're making a circle, but they're making a huge orbiting circle inside that circle. And this pad is made for these long stroke orbital polishers. So the question is, what have you changed about the foam to make them work with these longer stroke orbital polishers, whereas it makes it different from the traditional foam pads that aren't for the smaller stroke polishers?
Well, part of it is the foam formulation. So the actual foams in this line were chosen so that they perform even and consistently on long throw polishers. One of the things is when you involve chemistry and engineering into these different pads, one thing that you can do is make pads soften with heat. So it starts off more aggressive and then it will soften and get better. One thing about the long throw machines is that they generate a lot of heat, and and what I call a tearing action, because that orbit's so big, it's tearing the foam or pulling it. So what we do here is we have a line of foams that offer very, very consistent results regardless of how long you've been using them. So as it increases temperature, the pad is still going to keep that same feel and same consistency throughout your cycle.
Okay.
The design itself is a dual layer design. The backing is more firm. And
yeah, I feel that.
Yeah.
Now, that's the stiffer gray. So this gray portion is the same on all the pads, and what changes is the different colors.
Correct, yep.
Okay.
And what the backing does is it creates a firm backing material. When you look at the side profile of it, because it's tapered, it increases the footprint. So instead of just having the downward pressure from your backing plate, now you have a little bit extra, and it offers a balance between an exact fit pad, which is oftentimes very dangerous because your backing plate's right at the edge.
Sure.
So it offers that even pressure of that, but the little taper, so you're a little bit more safe.
Yeah, I like that idea. Now, there's also a hole in the center here.
Yeah.
What's the purpose of the hole?
Well, with all the new machines coming out, especially the long throw machines, most of them have a ventilated backing plate.
Okay.
And it's not just a center hole where the bolt goes. There are actually ventilated tracks throughout the backing plate to help release the heat that's created from these machines. So with the center hole, that's our main focus, is to center the pad, but also to give a channel for that heat to release.
And when we talk about pad longevity, because everybody that buys a pad wants it to last forever, but that's not true.
Yeah.
Nothing lasts forever, not even you and me.
Yeah.
Right?
No.
So the heat is probably one of the biggest enemies to any pad design, including the Velcro, the adhesives, and the foam themselves, correct?
Yeah, so the design offers a number of different things. For one, because of the dual layer design, it helps prevent the heat that goes through the ventilated backing plate from actually re-entering the surface material.
Got it.
So now we're only working with the heat that's coming from the panel and from the friction. The other thing that it does is it offers the same benefit that you get out of a thin pad, where you get very little foam movement, which what I call is molecular friction. You bend metal,
sure,
and it gets hot.
Sure.
So it's the same idea on the small strands of your foam. So if you can reduce the movement side to side, not only are you going to increase your power, but you're going to reduce your heat. So those two concepts right there help do that, but because it has a thicker design in that second layer, you get the benefits and the rotation of a full-size pad.
Got it.
That's one of the things that people oftentimes struggle with a thinner pad on a long throw.
So on these HDO foams, just since we're here right now, which are the cuttings, which are the most aggressive, which are the softer ones?
Yeah, absolutely. So this is a really easy system. The red one we just use for waxes and sealants.
Very soft.
Yeah, very soft. All-in-ones if you'd like. The black is what I choose for finish polishing on finicky or soft paint.
Okay.
If you use a polish that has top quality abrasive technology, even though it's a black foam pad, it has a little bit of body to it, and it will break down that abrasive and finish phenomenally.
Okay. Then we got the orange and the blue. Which is more aggressive in the orange and the blue in this line?
The blue is more aggressive.
Okay.
So the orange is what I would typically use as a go-to polish pad. This pad finishes phenomenally for me on almost any finish. The only time that I really use a black pad is when I'm using a glaze, or if I'm working on a Honda or Subaru or Porsche that has really soft paint.
The soft paint.
Yeah, yeah.
And then the blue is more aggressive cutting.
The blue is more aggressive. I'd like to consider it a light cutting or an all-in-one pad. It's very, very universal. I use it with finish polishes on harder clears or ceramic clears, but I also use it as a light cutting pad when you don't need a microfiber
With
pad.
compounds?
Yeah, with compounds.
Okay.
So whether it's using the Wolfgang Uber compound as a one-step or even the swirl remover as a one-step, this pad's super universal, and the one thing that's really unique about this blue foam is how consistent it is. So like we were talking about on other foams or different foams, oftentimes when you get into firmer foams like that, once you generate a little bit of heat, it softens. So you can either get an inconsistent result or an inconsistent user feel.
Got it.
And that's why this foam is so unique.
Okay, so now let's take a look at these pads over here, because they're kind of the same, but they're different. They got the hole in the center. They're quite a bit thicker, but they're missing that inner core of stiffer gray foam.
Yeah. So these pads are designed for use with gear-driven machines like the 3401 or that new Makita machine. They are a slightly thicker pad because that machine is different than a standard DA. We always recommend, or I'm sure you do too, is running with the pad flat on the surface.
Sure.
But because the gear-driven machine never stops spinning, you have an additional variable of downward pressure that you don't have when you're using with other DA machines because it'll just stop spinning.
Sure.
So when you have a thicker pad, it helps create that user feel where you can adjust your downward pressure to increase your level of cut or decrease to help yourself cut or finish better. These pads are designed a little bit different, kind of opposite from what this is, where because a gear-driven machine doesn't have the same type of movement, one of the things that people say that they like so much about a weighted machine like a Rupes or a Porter Cable or Griot's Garage is that it finishes so well.
Yes.
And being a gear-driven machine, it doesn't have the same finishing characteristics. Still great, but not the same. So these foams actually soften as you use them. So they'll start off with a deeper cut, and as they soften, it gives you a better finish. So
got it.
So yeah, so you would end up being able to do still the same 2 or 3 step process, not increasing steps in your polishing process.
Now this HDO line, we have this gray pad, an orange, looks like a white, black, and red. And this one here, I've used this before. This is really stiff. So this is like an aggressive cutting pad.
Yeah. Yep. So the gray is a new aggressive foam, and it's still a small celled foam, so it has that good finishing characteristic, even though it has a lot of cutting ability. But what's nice about this pad is this pad works phenomenal as a cutting pad in Wisconsin, and I use it regularly with my Flex 3401. But what I got to experience was detailing Barrett-Jackson auctions and working in your environment in West Palm Beach. The heat and humidity are a lot different. So what normally would work fantastic for me was mushy and didn't provide the cutting ability that I needed during these temperatures. It was about 98 degrees and humid. So this gray pad fills that void. This is one of the pads that does offer a little bit more consistency where it stays firmer throughout your heat, but it does that for a reason. So if you're in the upper Midwest or even on the West Coast where the humidity isn't as bad, you're typically going to cut with either a wool or an orange pad. But when you get down south, down by you, anywhere where there's hot, humid weather, that gray is going to be your go-to.
Okay, so these are good for gear-driven orbitals and rotaries.
Yeah, absolutely.
Okay, now over here, one of the things that makes these pads here very unique than all the pads we've looked at in the foam series is how thin they are. So what are these pads?
So these are our Thin Pro pads that are exclusive to AutoGeek. These are designed to, and they work on all machines, but for me they're designed for a Porter Cable machine or a Griot's Garage 6-inch machine because you can really maximize the performance out of it. And that's something that you have kind of been preaching for years, thin is in.
Thin is in.
Yeah. So it really maximizes that power from the machine to the paint. It doesn't actually create more power, but
yeah. So the way I've always explained that, and even though if you take a look at these two pads here, these are actually fairly thin in the context of foam pad history. Their early foam pads were about 1.25 inches, 1.5 inches thick, and that was just, you only had a few pads out there, they're very thick. You throw them on a free spinning tool like the Porter Cable, and that foam would tend to absorb a lot of the power coming out of the tool, and what that would show up to us, to our eyes at least, is the pad wouldn't rotate. So it's taking that energy and it's just kind of dissipating it.
Yeah.
And so when you reduce the amount of foam there, what you're able to do is take a tool that would normally possibly stall out on you, and you can maintain pad rotation.
Absolutely.
So that's where the thinness comes in. There's just less foam there to dissipate the energy.
Yeah, I would agree.
And these pads, by the way, they do work awesome on any of your 8mm free spinning tools, and there's a bunch of those on the market nowadays.
Yeah, and they work great on long throw machines also. One of the things about a thin pad is the weight, kind of like we talked about with the previous line, and how that translates into pad rotation. And there's a lot of people that love thin pads on their long throw machine, but one of the things is it's a technique thing. So it's a personal preference, and it can be challenging to adjust your techniques to curves and contour panels in order to get proper rotation.
Now, one of the things we talked about earlier, just to kind of wrap this up, is this here, this traditional foam pad, this is what's called an open cell. What's the opposite of an open cell?
The opposite of an open cell is this handy closed cell.
You just happen to have it in your back pocket?
It is Lake Country. So this is your Cyan Hydrotech pad. It's a closed cell, and how you can usually identify them is they usually look a little bit shinier because the cells are closed, so they have slight little thin plastic or polyurethane lenses between those holes.
It's a membrane, basically.
Yeah, it's a membrane, exactly. That's a perfect word for it.
So now, like, I can blow air through this. Can you blow air through that?
Nope.
Nope,
I
pretty
look
hard.
like a chipmunk.
So here's how I like to explain this. When you think about open cell and closed cell foams, imagine a window frame, okay? So open cell is like somebody broke the glass, so you have the frame, but the glass or the membrane is gone. Now with closed cell, you've got the frame, and with foam, you have thousands of structures, which are the cell wall structures, but that membrane is intact. So liquids or air can't go through it easily. Still can go through it, just not easily. That's the key word.
Yeah.
So that's the difference between a open cell and a closed cell. And then I know from talking to you that the other difference is open cell tends to have more tensile strength. So it's able to stretch, and it's a lot more forgiving, where when you go to closed cell, you've reduced the tensile strength, and that's why it's not as long lasting. But the benefit is you get them other features to it, like the performance over time of the characteristic of the foam itself.
Yeah, absolutely. I mean, it started as a European thing, and it provides a really high gloss, and it smashes or sandwiches abrasives to the surface. So it is definitely a unique type of pad.
So basically what we've learned here is there is a lot that goes into making a buffing pad, whether it's a fiber pad or a foam pad, how thick it is, how thin it is, the type of foam, the sharpness, the open cell, the closed cell. In Lake Country, these are the people behind foam pad technology that make great buffing pads, and what that does for us is it enables us to do our job, which is making cars, boats, motorcycles, RVs, even airplanes look great. Thanks, Dave, for sharing some of the science behind pad technology.
Thank you very much.